Down and read the objective for us, please.
I can identify the greatest common factor and read common multiple monomials.
Three together, 1, 2, 3.
I can identify the greatest common monomial.
If you notice, we're moving on from systems, because you already did plenty of practice with that. You did your home play and you're ready to go. We're moving on, and we're going back now to polynomials, because we're about to use polynomials now in equations. Yes, I know. So, today is going to be the first step. It's going to be a very simple lesson, which is something you already saw in elementary. For those of you that were with me in the summer, this is going to be very familiar because we already practiced this in the summer. That was the point of you being in the academy. Okay? Here we go. So, today we're going to be looking at GCF and LCM, and we're going to approach it in a different way, using Venn diagrams. So let me show you what it looks like using a Venn diagram. Those of you that use it in language arts, you already know that when you compare stuff, for example, what do I have in common with Michael Jordan? That's me. So let me use a Venn diagram. Here it is, Michael Jordan's and me. So, Michael Jordan, he's tall, I'm not that tall. Michael Jordan is a professional basketball player, I'm a teacher. Michael Jordan is rich, well, I'm not rich. However, the one thing we do have in common is that we both love mathematics.
And basketball.
And, yeah, basketball, but mainly math was one of the things that caught my attention when I was younger, when I started following him. Now, Michael Jordan is one of the few, or one of the professional athletes that are very wealthy because their accountants or their lawyers do not steal from them because they know their math. Believe it or not, there's a lot of professional players that have played either in NBA, NFL, or the baseball or hockey leagues that won millions of dollars while they were in their career, and right now they're delivery truck drivers working at Subway in construction because they have no money. They stole all the millions that they had from them because they didn't know their basic math. I know. I was looking at a documentary the other day, and I was like, wow, I can't believe this person. And then all of a sudden they started showing different players, and I was like, wow. And during their career, they made up to, I don't know, $50 million, $80 million, and then they ended up with nothing. Anyways, a little segue. So check this out. So what do we have in common? What we have in common is this part right here in the middle. Did I write my favorite subject, math, twice? No, only one time, because that's what we both have in common. We only write it once. This is what we call, for today's activity, we're going to find the greatest common factor, and this will be a greatest common factor for both. So first, what are factors in your Ferrier model? Write this down, please. Factors. Factors are two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. Examples. 2 times 5, 2 times 3 times 7, 3 times 5 times 11, 2 times 2 times 3 times 3 times 5. Copy that. Now, we've heard these terms before, right? When we got to multiplying polynomials, remember that? So factors. However, I want to clarify before we move on. So according to the definition, it says factors are two or more numbers that are multiplying. So what if I did this? This one times x. Are those still factors? Yes, because x represents an unknown number. Is that correct? What if I did this? Times y. Are those still factors? Yes. How about times negative 1/4? Are those still factors? Yes, because they're still multiplying. Numbers that are multiplying. Does everyone understand? How about times x, y? Yes, there's multiplication throughout. All those are factors. Oh, sorry. There it is. We good? Non-examples. As you're writing the non-examples, you already should know why these are not factors, right? Tell your neighbor, please, why are those not factors? All right, so as you're writing that down, start writing a couple of hashtags here for clarification of factors. Can you give me one? Hashtag multiply. How about multiply only? Okay. Why?
2 or more.
2 or more. Is that it? Hashtag math. Yay. How about hashtag variables included? Yes? Okay, copy that. Then I'll move on to the steps. So here are the steps. Don't copy the steps. I know it's very lengthy. There's 6 steps. So I'm going to get straight to an example, so that like that we can see the process. Okay. So example. Oh my goodness. Example 1. Copy this, please. Let me zoom in. What is the greatest common factor and least common multiple of 24 and 36? Copy that, please, and then I'll go over the example. All right, here we go. I'm going to go over the process first, and then you will copy right after. So for right now, writing utensils down, you'll finish copying a little bit. I'll give you time, but as soon as I'm done with the example. Ready? Okay. Like I said, you already saw these in elementary, but I'm going to put them together in one step. So here we go. First thing that we need is for us to keep in mind the first 5 prime numbers. First 5 prime numbers are 2, 3, 5, 7, and 11. Talk it over with your neighbor, tell them why those are prime numbers. Prime numbers. Okay, I heard something about division or multiplication. The simplest definition is that they only have factors of 1 and itself. What does factors mean? Multiply only, right? Mm-hmm. Factors of 1 and itself. So what is 1 times 2? 2. Is there any other numbers? Yeah, you can go into decimals, but since we're talking about prime, using it to the lowest terms without getting into decimals, so it's only 1 in itself. How about 3? 1 times 3, 1 times 5, and so on and so forth. So keep these 5 in mind. Are we there? So check this out. So I'm going to take you back to elementary, 5th grade. All right, kids. Right here, you're just paying attention, okay? Today we're going to write factor trees. Yay! Okay? So here we go. So the difference from elementary to now, I want you to start with one of these 5 prime, and it has to be one of the biggest factors, which is the one that divides evenly into 24, 2, but the biggest one is 3. So I start with 3. 3 times 8. From there, 8 times 4. I'm sorry, 2 times 4, and this is 2 times 2. These 3 times 2 times 2 times 2. The 3, 2, 2, and 2, those are prime numbers. But when I put a multiplication in between, these are known as prime factors. Why factors? Because they are doing what? Multiplying. Why do they multiply? Because if they multiply, they give us our original number. Are we there so far? Yeah. Let me look at this one. Which is the biggest prime factor that divides evenly? The 3, that's 12. 3, that's 4, 2, and 2. Prime numbers are 3, 3, 2, 2. As soon as I multiply them, they are factors, prime factors. Are we there so far? That's the first part. This should be a review, right? Here goes a part that might not be new for you. Here it goes. Pay attention, please. I need to find the GCF and LCM. I'm going to open up a Venn diagram. This corresponds to 24. This one corresponds to 36. Let me ask you, what factors do both have in common? 3 and how many 2's? 2. So 3 and 2 2's, 3 and 2 2's. Do I write it twice in here? No, only once. 3 times 2 times 2. Are we there so far? This part that we just filled in, that's known as a GCF, greatest common factor, which is 12. What was left over? Let me see. What's left over here? 2. What's left over on this side? 3. Once we get whatever's left over, now we can multiply. Check this out. We can multiply like this to get my LCM. 2 times 3 times 2 times 2 and times 3, 72. How can we check our math? Let's see. 2 times 36, what is that?
72.
What is 3 times 24?
72.
Copy that, please. Here goes the next one. Example 1Q. Copy 16 and 20. 16, 20. My first 5 prime are 2, 3, 5, 7, 11. Okay, so I gave you a little head start. You should have already started with this one or be on this one already. Here we go. Which factor of these prime factor divides evenly? 2. Again, 2. And again, 2. So this is 2 times 2 times 2 times 2. This one, which is the greatest prime factor? 5, 2 and 2. 5 times 2 times 2. Let's get our Venn diagram going. This one corresponds to 16, this one to 20. What factors do both have in common? 2 times 2. 2 times 2, that goes in the center. So my GCF is what? 4, very good. Because it's only 2 times 2, right? What's left over on this side?
4.
2 times 2, which is 4. I'll write it as 4, but if you want to write 2 times 2, that's fine. What's left over on this side? 5. Put a little multiplication. And now we can find our LCM. Let's see. 4 times 2 times 2 times 5, 80. And how do we check our work? Let's see. What is 4 times 20? 5 times 16? 80. That is correct. Yes? You got it? Show me with your fingers how comfortable you are with these. Okay? Good. Some 5s, 4s. All right, let's get to the funner one. Here we go. Example 4. Copy this. I want you to write 60x cubed, 72x to the 5th. You see, that's why all that practice that you've done in the past is going to pay off. 2 times 3 times, 2, 3, 5, 7, and 11 are for 5 prime, right? Here we go. Let's do this one together. What is the biggest prime factor that divides evenly? 5 times 12, circle the 5. How about this one? 3 times 4, very good. 2 and 2. So my prime factors are 5 times 3 times 2 times 2. What's left? The x cubed. How can we write that in factored form, everyone?
X.
Times x times x. Very good. Okay, let's do 72. The greatest of these prime factors divides evenly is 3 times 24, 3 times 8, 2 times 4, 2 times 2. So my prime factors are 3 times 3 times 2 times 2 times 2. How about x to the 5th? X times x times x times x times x. How are we doing? Good? Good. Let's get your Venn diagram. Start with the prime factors. What are my prime factors that we have in common for both? A 3 and 2 2's? A 3 and 2 2's. Let's see. 3 and 2 2's, yes. 3 times 2 times 2. What else do they have in common? How many of them? 3 x's for each side. There it is. X times x times x. So with that, up to right there. Oh, I'm sorry, I forgot to label this one. This was 60x cubed, 72x to the 5th. Okay. What is my GCF up to right there? 12x cubed. That is correct. What's left over on the left side? 5. Put a little multiplication sign right there. What's left over on the right side? The 3 and the 2. So 3 times 2 is 6, and then we got x and x. And with that, we can find our LCM. Is that correct? LCM. So let's see. What is 5 times 3? Times 2, times 2, times 6, 360. What is x times x times x times x times x? X to the 5th power. How can we check our work? Let's see. What is 5 times 72x to the 5th? 360x to the 5th. How about 6x squared times 60x cubed? 360x to the 5th. Okay, show me with your fingers how comfortable you are with these. Okay, let's see if you can do this one by yourself. Here we go. Negative 90a to the 5th, negative 72a to the 2nd. Before you get started, look up, please. Factor out the negative 1. So I'm going to write the negative 1 over here on the side for both. So now you're working with positives. Does everybody see what I did?
Yeah.
Okay. So now these are positive. The negative we'll add it at the end when we get our prime factors, yes? See if you can do that one by yourself. Start with here. Let's go. Oh, let me help you out with these. 2, 3, 5, 7, 11. There you go. You're welcome. Okay, let's see. The biggest one of these prime factors that, divides evenly in there is what? 5, very good, times 19, no, times 18, 18, my bad. And this is 3 times 6, and 3 times 2. So this is 5 times 3 times 3 times 2, times A times A times A times A times A. This one was 3 times 24, 3 times 8, 2 times 4, 2 times 2, 3 times 3 times 2 times 2 times 2, A and A. Hands, have you got up to right there? Okay. Your home play is a play sheet that I have up here. Come get one. Home play is a play sheet. There's tutoring today. Play sheet. So I don't see you. Have a good one. See you guys tomorrow. Bye.